last time was what? Confidence intervals with sigma known. All right, well, what if we don't know sigma? Okay, so we don't know the population standard deviation. Maybe we should just give a pop quiz for the 3 here and give their answers for behavior. Everyone else gets the same. Well, real life, you typically don't know the population standard deviation, right? Because if you did, there'd be no point in finding an interval for the mean, because you know the mean. If the standard deviation of the population is unknown, we can no longer use the Z distribution. And we can no longer use a normal distribution. Instead, we use what's called the student's T distribution, or just simply the T distribution. Suppose variable x of a population is normally distributed with a mean mu. For samples of size n, the studentized version of x bar is x bar minus mu over s divided by root n. And this has the T distribution with n minus 1 degrees of freedom. So now sample size matters more than just to determine if it's normal. This is a continuous random variable, right? So this will be a continuous distribution. As with all the continuous distributions, the area under the curve has to be 1. It extends indefinitely in both directions. The T distribution is symmetric about 0. As we let the degree of freedom increase, the T distribution will begin to look more and more like the standard normal, so the Z distribution. Right, so Z values were constant, weren't they? I asked you for the Z value associated with a specific area. There's only one. That is not the case with T values. The T values change based on sample size. Right? They change based on the degree of freedom. This makes it even harder to calculate T values and Z values. And we already had to use a table for Z values. So again, we'll be using a table for the T values. It's table C, which I will be showing off. So this now leads into our second case for confidence intervals. Single population mean, but now with sigma unknown. Again, first assumption has to be a simple random sample. Has to be a normal population, or you have to have a large enough sample size. So central limit theorem is satisfied. Standard deviation is unknown. Then the confidence interval will be given very similar, right? X bar plus or minus T sub alpha over 2 times S over root N. T alpha over 2 is the critical value for the associated confidence level and degree of freedom. So once again, that would be the margin of error. This is typically, I don't have my link here. So again, examples broken into 3 sets. By hand, the calculator, and then Excel. Snack company samples 23 stores. The mean days on shelf for a box of crackers is 22.64 days, with a standard deviation of 5.76 days. Assume shelf life is approximately normal. Build a 99% confidence interval for the true mean age at sale. Bless you. That doesn't give me a lot of hope. 23 days is the average time that a box of crackers is on the shelf. Means the crackers you're buying are probably already more than 23 days old. So I promise you they'd been in the warehouse for much longer than that. Sample size is 23. Since sigma is unknown, our degree of freedom is n minus 1, so 22. We have x bar. We have s. We have our confidence level too. 99%. What does that make alpha? As a decimal. You know what it was from last time. How do you find alpha? One minus your confidence level. What's alpha? Good. First, margin of error. It's T alpha over 2, S over square root of n. Here's the t-table. Right. What you'll notice, again, look at the top of the chart first. It's giving you area to the right. Which is fine, that's what we want. You'll have degree of freedom, and the chart only goes to degree of freedom of 200. Anything more than that, it's a Z. I don't think we ever have to worry about sample sizes that large. And then it gives you only what? 1, 2, 3, only 5 areas. Which means it's going to be a real problem if our alpha isn't one of those 5. What was our degree of freedom for this problem? I think it was 22, wasn't it? Yes. So what we need to do is come down to the degree of freedom 22, which is right here. And our alpha was what? We want alpha over 2. What's 0.01 divided by 2? 0.005, right? .819 is our t value. Now we already have S. And N. I got 3.386. That's our margin of error. Then the confidence interval, x bar minus that to x bar plus. $19.254 to $26.026. Consumer Group samples 14 stores for a certain microwave model, getting a mean price of $328.64 and a standard deviation of $15.49. Assume prices are normal. Find a 98% confidence interval for the true mean price. With a sample size of 14, what are our degree of freedom? One less than the sample. We have the mean. We have our standard deviation. What is our alpha? .02. We just need to find that critical value. There's degree of freedom 13. Alpha was 0.02. What's alpha over 2? .650 would be our critical value. Right? So we just need to find now margin of error. And since I got units here, I'm going to use the dollars. I have 10.97. Then your interval, remember, x bar minus e to x bar plus e. X bar is 328. 317.67 to 339.61. Again, make sure you can get these on your calculator. Make sure you know how to do the calculations. Commuter tracks gas mileage for 34 days. Find that they average 12.2 miles per gallon with a standard deviation of 2.1 miles per gallon. Construct a 95% confidence interval for the true mean miles per gallon. In this case, it doesn't matter whether mileage is approximately normal or not, because our sample size is large enough. With 34 sample size, what is our degrees of freedom? What was it? Write out the X bar. Standard deviation. I don't think we're going to need alpha for this one because we're going to use calculator. And so where we go last time was what? Menu, statistics, then confidence intervals, right? Now we want the T interval, or a one sample T interval. Again, if you're asked, you don't want to use data, you want to use stats. Yeah, we don't need alpha, and we didn't need degree of freedom here either. So we're going to have to enter our mean, our standard deviation, and our sample size, and the confidence level. This was 95%, right? So that's all we need. And again, we'll give you a summary of everything. But really, all we care about is the C lower and C upper. So this whole thing. Health study, 57 women ages 18 to 24 have a sample mean systolic blood pressure of 117.2 millimeters of mercury and a standard deviation of 10.3 millimeters of mercury. Assumed blood pressure is roughly normal. Again, that doesn't matter because our sample size is large enough. We want a 90% confidence interval for the true mean systolic blood pressure. Nothing I need to write down. T interval, stats. What was X bar? What's the mean? What's the standard deviation? 7. That was all that. No. Go. What's our sample size?
57.
And what is the confidence level?
90.
Put it as a decimal. That look right? Say 114.92 to 119.48. Real estate agent samples 46 houses. Mean price. Yeah, first I was mean price. 142,500. Standard deviation of 2,350. 98% confidence interval for the true mean sale price of houses. on Excel, let's see what these different functions do first. Okay, that's probably easy. Okay, so you're going to have to do a bit more work here. We want t dot inverse dot 2t is going to be two-tailed, which you don't have to worry too much about that right now. Just understand that's going to be alpha over 2. We need to enter the area, which is our alpha. Well, it was 98% confidence, right? What's alpha? That's what we'll put in. And the degree of freedom.
45.
What this will give is the t-value, your critical value. There for now. To find the margin of error. No idea what's going on now. Thank you. You're actually going to want the t-value, right? So that formula again. Times standard deviation divided by square root of sample size. So you have to manually put it in. Right, so that's the margin of error. is before we'll have to manually calculate the lower and upper, which is what? Margin of error, or I'm sorry, the mean first, minus margin of error, which was in B2. Right, and then mean plus margin of error. Equals first. And then what I'll do is I'm actually going to format these. Format. I can't see that, but format cells. That's a number. 2 decimal places. There we go. I'll just paste it like that. So you won't need to actually find the t-value. I'm just putting it on there to show you that's how you would find it in Excel. So we want a margin of error of at most 0.8. We're anticipating sample standard deviation is going to be about 3.3, and it's a 95% confidence interval. We won't determine sample size. Well, remember how we determined it last time? Remember, we came over to the margin of error and we solved for n, right? So if we do that here, That was what we would get, right? We have a problem. I think that t-score is going to depend on the sample size, isn't it? Because we need the degrees of freedom. So what's typically done is we use the z-score instead. For a 95% confidence interval, that z-score, 1.96. Times the sample standard deviation all over our E of 0.8. And we take the ceiling. And remember, we always round up. I believe I showed this last time, but I'll do it again. Ceiling.math is the ceiling function, and then we just put in what do we want to take the ceiling of. Okay. I'm missing. There we go. Now that looks right. $66. So remember those key formulas. This time, though, to find T, you're going to need to know your degrees of freedom, which is n minus 1, which I think is there. Otherwise, the method itself is identical. But also remember You use a t-score when you're finding confidence interval for mean with unknown population standard deviation. You use the z-score if your population standard deviation is known. So you have to read the question and see which standard deviation I'm giving you, sample or population. Good. So don't forget, we don't need it all next week.